What we have here is the intake manifold from a Dodge Magnum engine. And the Dodge Magnum engines are the 5.2 and the 5.9 liter. And that's going to be a 5.2 is equivalent to a 318, and a 5.9 is equivalent to a 360. So this is referred to as the kegger because it resembles a keg on top of the engine there, intake manifold. On the front here, this is where our thermostat's going to be and a connection to the water pump. We've got some ports there that we can connect for temperature sensors. On the side, we're going to have some ports here. That's going to be for the intake manifold vacuum. Right here going to be where our fuel injectors are, and then up top those are going to be our bosses to bolt the brackets that hold the fuel injector system. Throttle body is going to bolt on here, and in the back this is where our distributor is going to be. Some information that they're going to have on there is going to be the firing order, which is displayed right here, and also too they're going to tell us what the cylinders are if you weren't aware of that. 1, 3, 5, 7, and then on this side here we got 2, 4, 6, and 8. Looking at it from the bottom, a common problem with these manifolds is this plate here starts to leak. So if you were to look in from the top, if you were to look down these holes here after removing the throttle body and see any oil down the bottom, then that would represent that the plate in the bottom is leaking. The bottom plenum plate here is bolted on, and the reason that it leaks is because it is steel and the intake manifold is aluminum. So the two dissimilar metals expanding and contracting at different rates, and it ends up over time leaking. So what some people will do is they'll remove this steel one and they'll have another one made that's made out of aluminum, so then it's the same as the aluminum intake, and then that's one way to fix it. I guess other than that, you can just simply remove it and regasket it. Hopefully it lasts longer, or it fixes your problem. What I plan to do today is I want to play around doing a little bit of an experiment and modification to this manifold here. So the first thing we got to do is we got to just remove this plate off the bottom. And when we remove that plate, that's going to be a 7/16 wrench to remove all those bolts that are on there. So the first thing that I did was I came in here and I carved out this section of the center plate. So the center plate went all the way across, and I carved that piece out. When I did that, I just used the zippy wheel here, and I got it in there and I cut what I could, and then I used basically a hammer and a drift. Say for example on the end you could only get in here so far, so what I would do is I would make cuts like this up into my line, and then I would break those pieces off, and I'd just make sure that those cuts were close together so it would break where you want it to break. It's a little time consuming, but in all honesty, it did not take as long as one would expect. This is our general shape that we've got. I put a straight edge along here, it touched there and it touched there, and that gives us our line here. I felt personally that for me to try and get any further down in there would be impractical, and it would probably be too hard to do with the equipment that I've got. The next part of this whole scenario is to plug off all of this empty space that we've got in here. I mean, to me that seems impractical, and as far as flow goes, that can't be good, right? So what we want to do is we want to block all that area off, and so what I've done is I made some cardboard templates here to kind of figure out what we need to section that off, kind of block it all off, and then here's my straight line cut here. This'll go up to there. Now there's probably a couple different ways we can do this, and it depends on what methods you have available. I'll admit that I've tried welding aluminum before, and it's never a good thing, at least in my case. I suppose the best method would be using a TIG. I've used or I've tried to use the stick welder, and every time I've used the stick welder, I would not recommend it. It's just a complete waste of time and money. It doesn't really show a good product when you're done, at least in my experience. So if you were to weld this, if you're going to make those pieces out of aluminum and you were going to weld it, I would suggest probably going with a TIG. Apart from welding it, there may be some other methods we could use to try and achieve the same thing. What I've done here is realizing that I don't have the ability to do any aluminum welding. or trying to source somebody out to be able to do aluminum welding for me and the expense that might entail. What I chose to do was I went with like a epoxy product. It would be like a JB weld style kind of product. And what I did was I just kept applying it in little portions to basically seal up all this area here, and then again in the voids in here on both sides, because remember, this center plate goes all the way through. In fact, this is a portion of it here, and I left that in so I could use that as a rigid support when I'm applying the epoxy here. It helps strength wise. I filled in the void on both sides of this. I filled this in up here, and I did that on both sides. I did it over here and I did it there. I will leave it like that for the time being. I might get in there and I might try and maybe put in a little more product, or try and make this side match this side a little bit more. You can clearly see where I have this transition in here on this side and I don't on that side. One way or another, make them both match, and I could simply just add a little bit more material here, I guess, with the JB Weld product and match it up to this one kind of thing. And then we'll just regasket and put our plate on the top, and then we'll see how that runs. The point being, once we remove all that void space, maybe the air will flow a little better and cleaner into our intake runners here. The only other thing that I'd want to do before I install this thing is we'll gasket match our intake runners here. And once we get a gasket on there, we can kind of lay it out and see where we can grind off some material. Again, when you're doing this, all you really got to do is just hit this edge here. You don't have to go way deep into the runner. All you need to do is just grab that edge so you have an even transition from the intake manifold to the head. And you'd want to do it on both. You'd want to do it on the head and the intake manifold as well, if you can. I understand that if you're leaving the heads into the vehicle, you're probably not going to attempt that while it's on the vehicle. So if you have the ability to do both sides, do both sides. If you can only do one, do one. Every little bit's going to help. If anyone else is interested or working on something similar like this, feel free to throw some comments in and let us know how it's going. I won't be able to actually use this for a while. I'm just kind of getting it ready for when I do a job in the future here. Looking forward to see what kind of improvement we're going to get, eliminating all of that void space and trying to direct that airflow more efficiently into the runners. I do believe that it will make a difference. How big of a difference it'll make, I don't know.